Hello, welcome to Staadro Analysis and Design and Detailing. Here we are going to learn today how to use Staadro to do a detailed analysis of any type of structure. But what we are going to do today is analysis of a beam. This is an example of the beam we are going to analyze. This is a structure. Now this structure is gotten from our textbook Onyenuga, Design of Reinforced Concrete Structure by Onyenuga. So that is where this structure is gotten. Now you can see that this structure is a 5 meter span, 5 meter span structure into 1, 2, 3, 4, 5, 6. So six span and is a continuous beam like. So we are going to use Staadro to analyze it and compare it with their own solution, what their own values are. So that is what we are going to do at this point. So when we look at this, we're going to compare it with their results. You can see the analysis here. So, so this is the beam. This is the first analysis. So when we analyze this, we compare our values, the answers we got with their own answers. So from their own solution, you can understand that support 1 and support 2 is assumed to be a simply supported structure because the moments are zero. But for your information, for proper analysis, most times there is no free support in a reinforced concrete structure. Some of these things are done this way so that to make the design of the structure to be easy. But when you have your computer, when you are using the software to design, I oblige you to make sure that every point in that structure is fixed. So, but we are going to analyze based on what they have so that we can be able to um, know the moments they have. Okay, so that we compare their own answer with what we have in our own distance. So look at the structure. It have an equal span of 5 meter interval, center to center. That is a span. So let's work on it and see what you're going to get in our own analysis using Staadro. So let's go there. So what you do, the first thing you do is to click on new. Now we are working on a plane. Now you select meter and kilonewton, click next. Now plane add beam, finish. Now you see the kind of this thing we have here. So you can check back. Let me check the units we have. We have meter and kilonewton, so it's okay. So, but the kind of values we have there are in points. So first of all, you understand that the structure we want to solve is 5 meter span into 6 spans. Look at it, 5 meter spans into 6 spans. So how 1, 2, 3, 4, 5, 6. So 6 times 5 will give you 30 meters. So 30 meters. Um, when we look at here, we don't have up to 30 meters. So we create our own. We create our own environment. So click here, create. Now we change the name, create your own name. Let's say me. Then you change here, and maybe you say for every this thing space you have is maybe 2 meters. So 2 meters for every space. For that, this you can going to have 15. So it will up to 30. So we have that done. So you click OK. So you click this. So you can see it now. So we have 30 meters. So we have 5 till 30. So but you see what is going to happen here. This system does not accept something that does not match at the center of it. You know that um, 5, we don't have 5 here. 5 falls at this center, and there is no way you can draw it, but I'll show you how to handle such issues when it occurs. So what we do now is that we are going to accept 4 4. So here we say 4, 8, 12, 18, no, 16, 20, 24, 28. Then we'll have the balance. So we press escape and close this. So this is it. 1, 2, 3, 4, 5, 6. We have gone to we'll remove this one. 1, 2, 3, 4, 5, 6. So you can see now we have 6 span, but each of these spans should be 5 meters, not 4 meters. So we have to adjust it so that it will be exact thing that we want. So we'll go back to our nodes. Look at this. Node 1 is 0. This is node 1. This is node 2. Let me show you how to name your nodes. If you want to bring out your nodes, you right click on the screen and click on structural diagram. Then look for labels. Say nodes and OK. The system will bring out the nodes. This is node 1, node 2, node 3, node 4, node 5, node 6, and node 7. You want to bring out the um, dimensions. You click here for dimensions, and you say display, and it will comes out. Now you can see that what we have is 4 meter span, but I want to change it now to make it 5 meter span because that's the right thing we're supposed to have. So this one is 5 meters now. It's 10 meters now. It should be 15. You can see what is happening. 15, 20. So we'll have 20. You can see it. The next one is 25. And the final one is 30. So you can see that we have created our span. We have changed it, we have modified it from 4 meters to now 5 meter span. I believe you understand how these things are done now. Now, so these are our nodules. So these are the spans. If you come here, this shows you the nodule, node 1, node 2, node 3, node 4, node 5, node 6, node 7. And here it shows you the beam. Beam 1, this is beam 1. Beam 2, this is beam 2. Beam 3, this is beam 3. So this is how these things are outlined in Staadro. So after creating our beam, we have been able to create our beam. The next thing to do now is to begin to model it to look the same way it looks in the paper. So the next thing we create now is support. So this is support. Remember, in that support we have go to create. We have pinned, understand, and the pin support we have is click here, pinned restraint on all these sides, and so we add this one. Then we create another one. Um, the internal ones are still pinned, so because it's a continuous structure. So let's go this way and see what I will have. So there's no need of creating, since all of them are pinned. There's no need of creating much distance. So let's just cancel here and apply. So you assign these things to all of them. If it is just the same thing, you can assign with view. So we'll finish our application. So the next thing is add materials. Remember, if you don't add material to your model, the system cannot be able to analyze it. So I use define. I want to define my material. I don't want to use a pre-designed material. So I just use, for example, I say this column is 0.225 slash 0.4300. So I add it. So it's not required for me to add it to the structure. So I assign it, click on assign, and I begin to assign. So after I must have finished assign, I close. Now the next thing to do is to create our loads. So I create on load, click here, load case details. Now when I click on load case detail, I click on add. I say load 1 is a live load or dead load. I add it. Load 2 is live load. Add it. So I close. I go to case 1. I say add, which is self weight. Add it. Then I go to case 2. Which is a UDL load. So I use member load, and it is 5 meter, so uniform force. So you have minus 5, minus 54, minus 54 kilonewton, minus 54 kilonewton, like we can see from the drawing. And look at it here, this is 54 kilonewton per meter. So we go, so we type here minus 54 kilonewton. So the distance is 5 meter. So 5 meter. So at this point you click OK. So you close it, then you assign a load. I'm going to use assign to view for this because it's a safe weight. All of them need to be assigned at the same time. So for the next one, I'm going to assign with what? With my cursor. So I click assign, use cursor to assign. So I click on this and assign. So I assign here, assign here, assign here, assign, assign, assign. So I'll assign my load the same way you have it in the picture. Look at it. I have modeled this structure. And see how I've modeled this structure. So let's go back. And after placing your support, your load, and everything, the next thing that you need to do now is to go for your analysis. So but before you go to analysis, you go to analysis and print. Analysis and print. So when you click on analysis and print, the system will ask you the type of analysis you want to perform. It's a perform analysis. So you select what you want the system to print. If you don't want anything to print to show on the output, you say no printing. If you want load data, if you want static data, if you want static loads, anything you want. If you want all, you click all and you say add. So you click and say perform analysis. So the system will run the analysis. So zero warning, zero error, and you can see that this have turned. So this is the output. You click here. So this you're seeing is a kind of your analysis sheet, calculation sheet for the analysis. Um, but I love seeing my work, my analysis on the other side. So I close this one. I go to here, post processing. So okay. So this is it. So what you are seeing here is the forces. If I want for the beam, so this is you can see is the shape of the bending moment diagram. You can see it clearly. You can see the shape of the bending moment diagram. Here is 0, here is 5, here just like that. So you have the loading and the bending moment diagram. So when we come here, we now go from span to span. So the first, you have two case loads. But the case load we are interested in now is load case 2. The one we have 50, you have 54 kilonewton. What Staadro does is that it analyzes the structure based on the safe weight alone. Then it will analyze the structure based on when it is giving an applied load, like what we can see here alone. So the load alone on it, so we can be able to get the value. So let's go back. So here you can see M1 which is here and M7 which is here is equal to what 0 0. So let's check our one. So here load case 2 0, node 1 is 0 and node 7. So you go to node 1 and node 7. So this is node 1 and node 7. This is node 7. You can see that they are 0 0. So we are correct. So the next thing is node 2. This is node 2 for load case 2. So this is load case 2, node 2. Node 2, what is it? Minus 142.64. So what do they have? You can see it. This is 142 M2 and M6 142.74. You can see it 142.74. Let's go back. 142.64. So it's the same thing. So this same value is what the other value here is going to give you. You understand? So we go down to pin 3. We have gone to pin 2. Now we're going to pin 3. Pin 3 with load case node 2, node 3. So this is load beam 1, beam 2, beam 3. So we have beam 3 and we have node 1, node 2, node 3, and node 4. So we have node 4 and beam 3. So this is beam 3, this is load case 2, and this is node 4. So node 4, you have 116 at the moment. 116 at the moment. So you go look for it. This is it. 116.84. So you can see that Staadro can do the analysis perfectly. So you will now be rest assured that any value you are going to get from your Staadro is going to be a very accurate analysis figure that will be used for your design. Okay, so this is how we have gotten these values. So we have done the design. So this is analysis. These are bending moment diagram. So if you want to watch, you want to print this, you can expand it and look at it. This is your bending moment diagram. So let's see whether we can. Okay. So bring. So you have your bending moment diagram. If you want to see them in graphs, so this is it. When you click this one, you get your value. You click this, you get your value. You click this, you get your value 117. Remember, this one is 40 something. This one is 40 something. So this is the span moment. This is support moment. So just that way, 117, 117, 104, 113, going back, something 143, and this. So this is it. This is it, and at this point, this is the process of analyzing any structure. So what you understand is that you first have to model the structure very well, put the right supports, put the right loading, and the structure will be designed the way you want it. Thank you.